Exoplanets are some of the most difficult astronomical objects to detect. Unlike stars, they don't emit their own light. Therefore, astronomers have to get pretty creative in their methods to detect exoplanets. What we found is one of the most effective methods is using the transit light curve. This involves looking at a star and seeing how much light it emits over time. If you keep looking at the star, a planet orbiting it passes in front of the star, so between the observer and the star, we'll see the light curve dip. That's why it's called the transit light curve. In this demo, we use a luxometer, or a fancy light sensor, to detect how much light is coming from our star, in this case a light bulb, when our planet, in this case a styrofoam ball, passes in front of it. So from this angle, you can see as the planet orbits the star, it starts to block some of the light right as it passes in front of the star. So now we'll be able to see, as the planet passes in front, the luxometer will drop from about 235 units to about 210. There it is. And then once the transit finishes, you can see the luxometer back up to 230 units. And so this is actually one of the more interesting demos in the physics festival, because this is exactly what goes on in real life in space. It's just a much more scaled down version of it. The flux starts high, in this case about 383. Planet passes in front of the star, it drops during the transit, and then back up to normal. This is physically what is going on, and this is what a light curve, a transit light curve, would look like. It tells us all sorts of things about the size of the planet, the size of the star, the ratio of the two. It could tell us how close to the star the planet orbits, and that's why it's one of the most important and effective ways to detect exoplanets.